Good evening, everyone. Welcome to my class. Good evening. Yes. All of you, welcome to my class. Shall we start the class? Last class I explained reflection, then basic ray diagram, then how to draw the ray diagram, everything. Then today in the reflection, this is the last class. Okay. Reflection, this is the next class what I explained yesterday. That is I explained in detail about the basic diagram, everything. Today we will discuss last one. We will discuss reflection. This one is the part 3. Then today we will discuss convex mirror, then convex lens and concave lens, everything in detail today we will discuss. Okay. Shall we start the class? Tell me everyone hi. Then I will come to know how many are there or not, whether I can see the names also, who is there, who is present or not. Here showing 6 members are there. At least if you tell I, then if you interact with me, then I will feel okay. At least I will feel I am explaining someone. Otherwise what will happen if we will think no one is there. Yes, good evening Pratibha. Okay. Good evening everyone. Shall we start the class? Yesterday what I discussed, at least are you glanced? Anyone tried how to draw the ray diagram? Yesterday what we discussed? Yes, Lakshmi. Okay, all are there then. My regular, all the teachers are there. Okay, we will start the class. If possible, I will complete reflection today, then refraction. It depends upon your cooperation. If you are cooperate with me, then I will continue more classes. Otherwise, I will take only 2 hours. It will be depends upon you. If you are interested to listen the class, then I will take 2 hours, 3 hours also. If you tell ma'am enough ma'am means that time I will stop. Tell me. Okay. Then next one, image formation in the case of a concave mirror. Yesterday image formation we discussed in the case of a concave mirror, and I explained maybe 6 different position with ray diagram also we studied, and we studied in detail how to decide the nature of the image also. No need to by heart. If you know the ray diagram position, then easily you can with the help of the ray diagram, everything, seeing the ray diagram only, everything you can decide. Yes, no? Yes. Then the image formed in a convex mirror is always virtual and erect. What is mean by virtual means the ray we will get by diverging. Remember the name. Why I am writing every time means if you continuously if you are listening the same, it will get register in your mind properly. Virtual, then erect means remember left right, it will become like ulta, it will appear. That one we will consider as a erect image. Then which type of image we will get in the case of a convex mirror means always virtual and also left. Yes, Rabia, reverse. Then whatever be the position of the object in this section, let us look at the type of image formed by a convex mirror. When an object is placed at infinity, first they are given. If the object is at infinity, then a virtual image is formed at the focus. Here you can observe this is the position of the image. Then the object it will be at infinity. They are given at infinity. The size of the image is okay, we will discuss that one later. Here this is the I will tell how to write the ray diagram. Then this one is the convex mirror, this is the reflecting surface, outside is the reflecting surface, this is the reflecting surface. Then this is the principal axis, as usual draw the principal axis. Then this is the pole, then this is the focus point, then this is the center of curvature. Understood? See how we are writing in the case of a concave mirror means, concave we will write like this, then this is the reflecting surface, we will write pole here, then focus here, center of curvature here like this. But in the case of a, this is concave, this is convex. But in the case of a convex mirror, why it is not writing properly? In the case of a convex mirror, this is convex. Okay, then in this case you can observe here the pole, it will be the center of curvature. This is the reflecting surface. Then back of the reflecting surface we will write the focus, we will write the center of curvature. This is important point you have to remember. But here in the case of a concave mirror, pole it will not at all change in the both the cases also. But in the case of a concave mirror, in front of the reflecting surface, this is the reflecting surface, we will write focus, center of curvature, then here the position of the object, everything. Then here this is the reflecting surface, position of the object it will not change, but you are writing back side of the reflecting surface, you are writing focus, you are writing center of curvature. Don't write F and C here, this is wrong. Okay, you have to write back side of the reflecting surface, that you have to remember in the case of a convex mirror. When you are drawing the ray diagram, you have to remember. Then here the rays, because you are keeping the object at the infinity, then from this one consider one ray that is parallel to the principal axis. Already yesterday I told always it will passes through the focus. Yes, like this it will passes. This is only the imaginary line you consider. Okay. Then here this is the F. Then here this ray, after this is the reflecting ray, then this ray is parallel to this principal axis. After hitting the mirror, it will get reflected in this direction. This is the incident ray, this is the reflected ray. But here after hitting the concave mirror, it will reflect in this direction. Then according to yesterday rule I told, if any ray is parallel to the principal axis, always it will passes through the focus. But here the ray it will not passes, because already it will hit the mirror, it will reflect in this direction. But if you extended that reflecting ray, then it will meet at the focus. The extended ray, this one only we will call it as a divergence. Otherwise divergent ray, diverging everything. Then here consider one more ray parallel to the principal axis. Then this ray also after hitting it, this is the incident ray, then after hitting the surface it will get reflected. Then here back side you have to extend this reflected ray. This also it will meet at a single point. Then this is the position of the image. Here in this case you are actually these two rays, actually you can observe these two rays, actually they are not meeting, correct? No, they are appear to meet. After extending they are appear to meet. This type of image we will consider as a virtual image. Virtual image or convergence or convergent, anything you can consider. This type of image only we will consider as a virtual image. Or this points, this reflecting rays, they are not at all, actually they are not meeting. When you are extending backward only, they will appear to meet at the point F. This is the position of the image. Understood everyone? This is applicable only in the case of a convex mirror. Are you following? Tell me, anyone? Yes, then I will move to the next one. Then here you can decide, at if you keep the object at infinity, then here how the virtual image it will form means after extending these reflecting rays, it will meet at the single point. Therefore, the image is virtual. Then what is the position of the image? The image it will form at the focus. This is the focus. Then here the size of the image is much smaller than the size of the object. Here also no need to, sorry, I had this one. Remember to draw a ray diagram. Always remember, in the case of this is convex, no? Convex mirror, we will get a virtual. In your mind, you have to think after extending only the rays they will meet. That much remember, then easily you can draw the ray diagram. I will move to the next. Only two cases are there in the convex lens. Not in the case of a concave. Yesterday we studied 6 different cases, but here only we will study 2 cases. That's all. When an object is placed at finite distance from the mirror, finite distance. This is the mirror. If you keep the object some distance from the mirror, a virtual image is formed. Always remember, it will form a virtual image is formed between the pole and the focus. It will form between this is the pole and also this is the focus. This is the image. This is the position of an object. Then where you are getting the image between the pole and the focus, then size of the image is smaller compared to the size of the object. We will draw the ray diagram. Then once again we will discuss. Listen here, consider. This is the convex, then this is the ray, this is the reflecting surface, this is the pole. You are writing back of the reflecting surface, focus and also center of curvature. Then here assume you are keeping the object some distance from the pole, otherwise some distance from the mirror. Okay. Then here also consider 2 rays, one ray is parallel like that. Consider first parallel ray, then it will hit the surface, it will like this, it will move, then extend, then it will meet at the point focus. That is one case. Okay. Then another case I explained, no, if the ray is passed through the center of curvature, again it will reflect back in the same direction. Then consider one more ray. This ray it has to pass through the center of curvature here. Okay, then again it will reflect back in the same direction. See the arrow mark? It will come here. Again it will hit the surface. It will reflect back. That's why in this direction. Here both the rays also you have to extend. Then the image you are getting here. Don't see my diagram. It will not proper. See this diagram. Here first ray you have to consider. Here it is not looking like a parallel, but here you have to consider. Today only after the class draw this ray diagram, exactly draw parallel to this principal axis, definitely you will get. Okay, parallel to this principal axis, it will reflect back, extend, it will passes through the focus. Another ray you have to consider like this. That ray it has to passes through the center of curvature, again it will move to the same direction. This is the second rule what I explained yesterday. This is the first. Both extend backward, they will meet at a single point. This is the position of the image. This is the virtual image because the rays, reflecting rays, they are not at all meeting. They will appear to meet. Okay, then you can tell me the nature of the image. The image is virtual, erect, and also here the size of the image is smaller compared to the size of the object. Understood? Yes, it is easy only. Those who are there in yesterday class, definitely you can follow. Those who are new today class, definitely 100% you are not able to follow. That's why at least physics, maths at least you can follow if you joined in the middle. Also if you missed 1 or 2 classes also. But physics, if you don't have any continuity in the same topic, means you are not able to. Okay, here what I explained, the 2 condition I given here in the form of a tabular form. You can revise this one. Then next one, yesterday someone is asking, no, Pratibha or someone is asking, ma'am, what is the use of, where we will use the convex mirror or concave mirror, something you asked. Okay, now listen here. What is the use of the convex mirror, where we will use to see the rear view of the mirror? Rear view mirror, the side view mirror of the car forms a small and erect image with the help of a convex mirror, which helps to see the way behind the car. In car, then vehicles, we will use the convex mirror. Which type of image it will form? The convex mirror, the image it will be small. Even the big truck is following you, you can see the truck, it will be very small inside your mirror, correct? No, therefore the image it will be small, and also it will be erect. Erect means, right, it will look like left or right, it will become change, they will be not invert. Invert is different, don't get confused with erect and invert. Invert means fully ulta, up and down it will become ulta, but erect means like right or left it will become like change. Then in which, where we will use the convex mirror? Next one, security mirror in ATMs. Security mirror are kept near the ATM so that the bank customer can check the somebody is behind them or not. Okay. Now, if you want to draw your money from ATM, then you can see if anyone is there in backside, anyone is observing you or not. That's why to monitor that one, they will use the convex mirror. This one I not observed. If I go to ATM, definitely I will see where they will keep. Because normally to draw amount, we will not go. Nowadays, like online payment only, it is there, Paytm is there. Everything is there. If you have the mobile, we can do money transaction easily. No one will keep the hard money now. Okay, next one. What is the use of a concave mirror? Satellite dishes. You can see this dishes, satellite dishes. Inside dishes, inside you can see this is the reflecting surface inside. Okay, it is like this. Inside is there, no, this inside, this is the reflecting surface, and this is made up of which type of mirror? That is a concave mirror. What is the use? One of the most important use of a concave mirror is satellite dishes. These are used to receive the weaker signal sent from the communication satellite and then amplify. Already I told how we will get the signal. Communication satellite means the satellite continuously it will be revolving around the earth. Then it will gives the information with the help of the signals. Okay, that satellite it will send the signal. Then to receive we need some more instrument, no? Signals are they will be roaming in the atmosphere. If we are not having the proper receiving satellite, then how we will get the signal? Then that communication satellite it will send the signal in the weaker format. Then this satellite dishes, what it will do, it will amplify it, otherwise it will convert into a stronger signal. Okay, the signals strike the concave mirror in parallel rays, get reflected back. These reflected rays are concentrated at the focus of the mirror. The main purpose of the mirror is to gather weaker signal coming from the larger areas, concentrate at the one point. Whatever the rays they are coming, they will get concentrated at the single point at the focus. Then whatever you are getting the signal in the form of an image, 100% accurate signal you will get. Understood in detail what is the use of the concave mirror? Then next one. Then one more use of a concave mirror. Headlight in a car. A powerful source of light is kept at the focus point of the concave mirror in a smaller space at back of the headlight. Any light striking the mirror from the focus will get reflected parallel to the axis of the concave mirror. Here the headlights, we will use the concave mirror. Okay. Explanation, it will be same what I explained in the same diagram. How the concave mirror it will work, that one you have to remember. Then shaving mirror, another use of concave mirror is shaving mirror. The image formed after the reflection of the concave mirror, it will help the people by shaving. It will give the magnified image. Correct now? Those who are normally boys, they will do the shaving now. Then it will be easy for them because they will get the magnified image. Okay. Then that mirror it will be made up of a concave mirror. Then next one, next dentist mirror, the concave mirror. Dentist also they will use the concave mirror because the concave mirror it will give the magnified image. Magnified means larger image it will get. Okay, clarified, magnified, and also even larger accurate image you will get. Dentist to focus the light on the tooth to be examined. Today I included few MCQ questions. Solve this one. Solve this one. What I explained from yesterday. Only few we will discuss. Then after I will move to the refraction, if possible. Otherwise tomorrow. Okay. Even continuously I can't talk in physics class. I don't know why. Live classes I am getting more tired. Yes, do it. When a plane mirror is rotated through a certain angle, the reflected ray turns through twice as much the size of the image. Tell me the answer. Tell me the answer. What is the answer here? At least try. When a plane mirror is rotated through a certain angle, the reflected ray turns through twice as much as the size of the image. If it is double of, become infinity or remains same. We will see what is the answer. Option D is the correct answer. Very good. Who is given? So many they are given. 3. Rashmi, Pratibha. Yes, it will be remain same. Yesterday also when I am explaining the plane mirror, I explained if you, it is where it went. Okay. If you stand in front of the mirror, what will happen? Whatever you are the image, if you go near to the image, then the size of the image, the size of the object both also same. If you go far from the plane mirror, then how much far you are from the mirror, that much the size of the image and object, it will not at all change. It will be remain same. This only in the case of a plane mirror. Don't get confused with the option. They are given doubled. Becomes infinity, it is halved, everything they are given. Always remember, in the plane mirror, the size of the object, it will be exactly same as the size of the image. Next, try. Next. At least try. If you give wrong answer also, no problem. When which statement is true for the reflection of light? Easy question. The angle of incidence and reflections are equal. The reflected ray. This is like first law of reflection. What is the correct answer? Yes, easy. The angle of incidence, it will be equal to angle of reflection. It is the correct answer. Correct now? Option A is the correct answer. Easy question. That is nothing but law of focal length of a plane mirror is. This one you have to remember. What is the focal length of the plane mirror? Yes, Suma Devi. Angle of I, it will be equal to angle of R. First law of reflection. Focal length of a plane mirror, maybe you don't know. I will tell the answer that one because that is fixed. No, infinity minus 25 they are given. Minus 25. This one you have to remember. What is the focal length? Focal length, small f. What is this value in the case of a plane mirror? Minus 25. Remember the value. That's all. Remember the value. No, Isha. It is not infinity. It will be minus. No, it is infinity is then. No, oh, sorry. I thought of D. No, B is the correct answer. Infinity. Focal length of a plane mirror, always remember that is infinity. This questions I not read before. This one I prepared. That's why even I had a confusion. Focal length of a plane mirror, always remember it will be infinity. Value is infinity. Next one. Yes. A beam of light incident on a plane mirror forms a real image on reflection. The incident beam is. This you have to give the correct answer. If anyone give the wrong answer, when you will get the real image. Think and give. I explained so many times. Yesterday also. 2 hours I explained. When you will get the real image. Very good, Rabia. Convergence, convergent, both also same. Don't worry. Yes, very good. Real image you will get in the case of a convergent. When you will get the virtual image you will get in the case of a divergent. Remember. Yes, very good. Yes, I will move to the next. Solve next question. This one you have to draw and you have to tell. At least guess. An object is placed at a distance of 40 centimeter in front of a concave mirror. In front of a concave mirror. This is the concave mirror. In front of the mirror, how much? 40 centimeter. Okay. Then focal length. What is mean by focal length? The distance between the, consider this is the pole, then this is F, this is the center of curvature. This distance between the pole and also pole and focus point is there, no, that we will call it as a focal length. This is the focal length. Then this one is 20 centimeter, here they are given. Then tell me the nature of the image. D, option D is telling Veena. Which type of image you will get? Yes, option D is the correct answer. Very good. In the case of a concave, always you will get real image. You have in these two option also, but leave inverted and of the same size as that of the object. Okay, real and also it will be inverted and also same size as that of the object. This you have to draw the ray diagram and also you have to clarify. After the class, take scale pencil, then from pole measure 40 centimeter. Okay, then focal length it will be 20. Otherwise you can reduce these values also. Then you can try which type of image you will get. But remember, you will get the image real, inverted, and also same size as the object. We will move next question. Tell me, which type of image you will get in a convex? Now only I explained. Which type of image you will get? Lakshmi, why B? Convex you will get real image. Hmm? Which it will be virtual, no real. Real we will get only in the case of concave. Now only we solved one question, no? Huh? Virtual is the correct, because in the case of a convex mirror, after extending means after diverging we are getting the image, correct, no? After divergence, after diverging, otherwise divergent you call, we are getting the image, no? Option A is the correct answer. Don't get confused. Next question. A student studies that a convex lens always form a virtual image irrespective of its position. What caused the convex mirror to always form a virtual image? Why always? I told. Why in the case? Why convex lens or convex mirror? Why it will always form a virtual image? Because of the reflected ray never intersect. Because the reflected ray converge at a maybe this one single point. Because incident ray traces its path back along the principal axis. The incident ray of a convex mirror get absorbed in the mirror. What is the correct answer? Tell me. Rashmi, what is mean by convergent? Convergent, you are getting a real image. How many times I am explaining? Then how you are telling option B is the correct answer? Again, here understand the question. Here they are asking the convex lens, convex mirror, both also same. Which type of image? Virtual image. When you will get the virtual image? When you will get? When you are divergent ray. What is mean by divergent ray? They will not at all intersect. After extending, they will appear to intersect. Correct? No? Then only you are getting a virtual image. Then again you are telling B. Think and give. Yes? Rabia, she is telling, because the incident ray traces its path back along the principal axis. Option A is the correct answer, because the reflected ray never intersect. They will not at all intersect. See, like this I explained, no, last I don't know how we wrote. Okay, I will write like this. Then one more we will extend here. Okay, one more like this we will extend here. This extended ray, it will appear to intersect. It will appear to intersect, correct? No, but any this is the reflecting ray, they are intersecting. They are intersecting. This ray is moving this side, this reflecting ray is moving this side. Can they? No, they will not at all intersect. Option 1 is the correct answer. Extend that intersect, ma'am. Yes, this only imaginary. We are imagining. This is imaginary. We are imagining the position of the image, but actually they will not at all intersect. They will appear to intersect. This is the Actual reflected ray, this one, this one. If this is moving in this direction, this is moving in this direction, where they will meet? They will not at all meet. Remember, this is in the case of a virtual image. Don't get confused in the exam also. That's why even virtual and real, whenever I will see the word, I'm explaining the same, because concept has to clear. Don't get confused. Okay. Here, if you confuse, okay, but don't get confused in the exam. Magnification produced by a rear view mirror fitted in vehicle is less than 1, is more than 1, is equal to 1. Okay, this I know, no one know the answer. Always magnification we will use now in in a car, that in that case the magnification always it will be less than 1. Remember this one. This is new. Okay, they will a magnification it will be less than 1. I not explained this one. Remember. The image of an object placed in front of a convex mirror is formed at this I explained. The object itself twice the distance of the object in front of the mirror of the distance behind the mirror where you are getting the image. I will write diagram, okay? Then you tell me. This is the position of the object. This one ray it will go. Here I will explain. Another ray I will consider like this. Okay. Then this is the position of the image. This is the object. Here I have to write ulta, no? This one, why I wrote wrong? Okay, sorry. This is, I have to consider which type of mirror. I have to consider here what? Convex. Convex, this one, no? This is the reflecting surface. This is the mirror. Where you are getting, in front of the mirror or behind the mirror? This is the in front of the mirror. This is behind the mirror. Then where you are getting the image? In front of the mirror or behind the mirror? Veena, understood? Rashmi. Understood, Veena? Before my explanation, maybe you given the answer. Answer D is the correct answer, because here this is the reflecting surface. Always in the case of a convex mirror or convex lens, the image it will form behind the mirror. Okay, don't this topic it will look like simple reflection, then concave, convex mirror, everything, but you have to clear about the concept, then only easily you can answer the question. Otherwise we will get confused in MCQ. Writing theory is okay, we can write the theory, yes, but solving MCQ problem it will be little difficult if you don't know the concept. The full length of image of a distance tall building can definitely be seen using which type of mirror? I am having very tall building, okay, then which type of mirror you will use? Then you can make the size of the image small. Tell me. Concave mirror, convex mirror, plane mirror, both concave as well as plane mirror. B. Shall we check the answer? Everyone they are telling B. Yes, answer B is the correct answer. This one, remember, I explained truck and also car. Correct? No, even the truck is very big. In the mirror of the car, it will be appear small. Consider any big vehicle. If it is following you, then you can, that convex mirror, it can convert in terms of a small image. Today also only 10, 11 are there live. Okay, next. Which of the following can make a parallel beam of light from a point source inside on it? Which of the following parallel beam of light form a point source inside on it? Yes, what is the correct answer? Tell me. Option A is the correct answer. Both concave mirror as well as a convex lens. Both. In both, already I told what is the use of concave mirror or convex lens. Any big object is there, you can make that image to a point source, like a point appearance, like make it as small. Even you can make it as that one as a point object also. Then you have to remember both concave mirror and also convex lens. Okay, both they will do the same. Then I will move to the next point object, in which case they will convert in terms of a point object. Remember concave mirror and also convex lens. I will move to the next one. Tell me, image formed by a plane mirror. Which type of image you will get in the plane mirror? This so many times I explained. No, Rashmi, in the plane mirror we will get virtual and also erect. You stand in front of the plane mirror, you are getting your right and left. This right left it will become like ulta. Virtual means, why it is virtual means, you are getting the image exactly on the mirror, you are not getting on the screen. If you are getting on the screen, that is real, but you are not getting the image on the screen, you are getting exactly on the mirror. Correct? No, therefore that is virtual and also erect. Don't get confused, don't get confused. In which case you will get a real image. Concave you are getting a real. Don't get confused. In convex mirror you will get a virtual. Even plane mirror also, plane mirror also you will get virtual. Don't get confused. Next. Next question. Tell me correct answer. A concave mirror gives a real inverted same size of the image if the object is placed at this type of question easily you can answer when you remember all the 6 cases is there, no? 6 cases yesterday I explained in the case of a concave mirror. If you revise that one, I given the table, no? If you revise that table, then easily you can answer this question. What is the answer here? The answer, it will be at C. Very good, very good. Veena, Rashmi, Isha, all are giving correct answer. Very good. At C. At C, if you keep the object at C, object you are getting at C also image. Object also it will be in same position. Image also it will be in same position. Then the image is real, inverted and also same size. At C you are getting same size. Real also inverted, ulta. Remember the case, then easily you can answer. Next one. A convex lens focus a real point sized image at the focus the object is placed at. Tell me which case you will get. At least guess. After the class, you have to revise that table, what I given now. Convex lens only we will get at two case. Only two case we will get. Yet. Only two case, but first one is at infinity. Another I explained if the object is in front of the lens. Yes. Option C is the correct answer at infinity. Yes, next one. The radius of curvature of a mirror is 20 centimeter. The focal length is, here I will write the formula. Focal length, it will be r divided by 2. R means radius of curvature divided by 2. Here what is the value of radius of curvature is 20 divided by 2. Then what is the answer? 10 centimeter. Remember the formula. Radius of curvature, focal length, it will be half of the radius of curvature. Veena, how 40? When I when I call Veena, immediately she deleted the message. No, no, no. I am not scolding. Simply I will tell. Okay. I will move to the next question. Answer. This question, this type of questions you have to remember. Okay. A concave mirror is produced. A concave mirror produces a magnification of plus 4. 4 times it magnification, it will be 4 times greater. Okay. The object, where you have to place the object. At least guess. Okay. I know this question is difficult to guess. At least guess. Magnification in which case you will get? At the focus, between the focus and center of curvature, between the focus and pole, behind the center of curvature. Yes, between the focus and center of curvature. Sajida is telling. We will see what is the answer. Between the focus and pole. Here, remember in the case of a concave mirror, this is the concave mirror, no? Then here, this is the pole, this is the focus. If you keep any object between these two, then you are getting the image is very enlarged image you will get. Very magnified image you will get. This one you have to remember. If you keep the object between the focus and pole here, then you will get very magnified image. Here you will get a virtual image. Actually, they will not meet. They will extend. They will appear to meet like this. Somewhere like this it will come. You will get a magnified image. Remember. Practice 1 or 2 times. Then easily you can remember. Don't worry. Next. If an object is placed symmetrically between two plane mirrors inclined at an angle of 72 degree, total number of image it will be formed. Option B, 4 images it will be formed. How 4? See, they are telling symmetrically plane mirror, two plane mirror. Angle is given. Leave that angle. Angle is not important here. An object is placed symmetrically between two plane mirrors. Plane mirrors are symmetrical. Okay. Then here one person is standing here. Then this person image, it will form on the another image. Okay. This is object. This is image. Then this is the first mirror. This is the second mirror. Then in the second mirror, the image of this man, it will be the image of this one also. No, here also you will get one more. Yes, again this one, it will get reflected. In the plane mirror, how many images you will get? 4. No, 5 you will not get. 4. When you are having 2 plane mirrors. In your home, if you are having 2 plane mirrors, keep one pencil in front of the mirror, then in front of 2 mirrors, symmetrical mirrors, then you observe how many images you will get. 4. Because why 4 means this is object for this one image, then this image it will act as object. Okay, then here one more image it will form, then again this one it will get reflected. 4 you will get. This practically you have to do, then only you have to come to know. But it is inclined, but only 72°, not that much. If it is inclined to like 10°, 20°, then you will get a major difference. But here 72 is almost, it will be equal to 90°, no? Like almost. With the help of formula, tell me Rashmi which formula? I don't know the formula. Tell me if you know any formula. Tell me if you know any formula. Oh, 360 divided by n. Okay. Then 360 divided by 72. You will get this is 10 divided by this is 2, no, then you will get 5. Then what is the formula? Minus 1, you will get 4. Okay, this formula is 360 by n minus 1. Yes, using the formula also you are getting the same. She is telling very good, Rashmi. She given one formula 360 divided by n minus 1. N is the angle. 360 divided by 72 do, you will get 5. 5 minus 1 is 4. Yes, using the formula also you can. If you know the formula, it will be easy because they will give different angle, no? Yes. Understood everyone? No one have the doubt, no? This I will erase. Using the formula, it will be easy compared to this. Yes. If n is odd, then same number. Okay. Okay, this formula I will check if any information I have to add or not. 360 divided by n. I will, don't worry, Isha, I will refer this one, I will tell in the next class. Don't worry. Understood everyone up to here? Except this one, don't worry, I will tell. I will search, I will clarify, and I will tell this one. Yes, if you have the doubt, you can ask me. Yes. Almost how many minutes over? Almost like 1 hour. Almost it will be finished. Are you reading everyone? Yes. Now 6 o'clock time. Can I take 6:30 to 7:30 one more maths class? Okay. Otherwise, maybe if I explain the refraction, maybe you will get bored. One more. If you are interested, I will take one more physics class. Otherwise, we will. I will take class. Maths only. Tell me if you are interested to listen one more physics class means I will do refraction. Otherwise, better I will take tomorrow only. Correct now? Because sorry, Sunday only less you are there. Okay, one more last class I will take now 6, 7, 6:30 we will do maths. Two physics class means you will also get bored. Better freshly tomorrow we will start the refraction. Huh? Because so many concept if I tell one day also you will get confused. We study detail about reflection. Refraction tomorrow I will take. Tomorrow also. Tomorrow is Monday, no? That's why tomorrow 4 to 5 I will take. 4 to 5. Don't. Oh, Isha is telling you half an hour break. Okay. Shall we meet at 6:45, Isha? Shall we meet? Maths in which topic? Maths. Maths. Yesterday I explained algebra, no? In algebra, factorization of the terms. Still, I told still difficult problems are there. Maths I will take. Okay, maybe 40 to 45 minutes. I know Sunday maybe you will not feel the so many classes. I know. At least maths you will not get that much. You can follow. Okay, we will meet exactly at 6:45. 6:45. 6:30 or 6:45. Take only 20 minutes break, no? If 6:30 to 7:30, if the class is finished means you can take rest. Hmm? Shall we meet at 6:30? Isha? Hmm? Okay, next class it will be at 6:30 because I also having some other work. Then we will meet at 6:30. Okay, 6:30 another maths class. Okay. Okay, bye everyone. Take care.